In the last few videos, I've explained to you in very broad general terms the theory behind deep learning neural networks. I hope you like my videos. I don't want to confuse you with mathematical equations and advanced mathematical concepts. Just I want to give you broad general understanding behind how the deep neural networks work, because ultimately we'll be using the TensorFlow, PyTorch, and Keras library. So everything is done for us. We just have to understand that theory so we can build better models. We don't have to build these models ourselves. We'll be using the TensorFlow framework, PyTorch, and Keras. So after these videos, I'll introduce you to TensorFlow and Keras. Now, I've told you about forward propagation. Forward propagation is when we pass the data in the forward direction from input to the first hidden layer, and then from the first hidden layer to the second hidden layer, and then to the output layer. We can have as many hidden layers as we want, but there's some formula, as they say, there's some method to the madness, because too much hidden layers won't give you anything. So you have to think how to design your neural network. There are some rules of thumbs or intuition involved. So don't worry about that right now. So I've told you forward propagation. Forward propagation is we pass the data in the forward direction. Then we compare with the actual. Once the data reaches this output layer, we compare the prediction with the actual, and there's an error. So now we pass the data in the back direction. When we pass the data in the forward direction, we are using weights. Each layer has got its weight and bias. So the data is being manipulated with these weights. Uh, what we have to do is to find the optimal values of the weights that minimize our loss. Loss, I have said, is that difference between the prediction and output. So, and I've told you about mean square error loss, but in classification we have different forms of losses: cross entropy, and binary entropy, log loss. So when we use, I'll explain to them. But general concept is the same. Just we have to understand that we have to calculate, may ensure that the difference between the actual and the prediction is as low as possible. So once we pass the data, we use certain values of the weights and bias over here in the first layer, then certain values of the weights and bias in the second layer, and we reach over there. So now there's a discrepancy. So we have to adjust the weights and bias. So we move the data now in the backward direction. First we move it in the forward direction, now we move it in the backward direction. And for that we use that gradient descent. Once we move it in the back direction, we want to minimize the loss. So that's why we are moving in the back direction. How we minimize the loss? I told you we use the derivative. That is a concept that was taught in calculus in high school and college. But if you haven't, don't worry about it. This derivative is taken of this loss function, and the first layer derivative is used to adjust the weights and bias over here. Then this layer derivative is used to adjust the weight and bias, and then we reach this. So this is known as one iteration. Now again we make a forward pass. Now this time we are using the weights and bias that we had calculated in the previous iteration, backward pass. This backward pass is known as back propagation. This is a very important concept in neural networks. So we again pass it Then there's again compare it with the actual, then again do back propagation, adjust the weights and bias. So after a number of iterations, we have a pretty good values of weight and bias that can give good predictions. So this is how we do it. I've told you that we use stochastic gradient descent just to ensure that the training time is reduced. We just randomly take samples from the input data, and then we do forward propagation and then back propagation, calculate the weights. So back propagation is the most important thing because back propagation discovery or the development of back propagation made deep learning neural networks possible. Because without back propagation, we cannot know the optimal values of weight and mass for our input data. So now you must be clear with what back propagation is. Once we calculate the derivative, so we use the chain rule because these weights and masses they are parameters, and once we take derivative with one weight, so we have to keep other weights and masses constant. So this is known as in calculus we take this derivative using the chain rule, but we don't have to worry about that much because I've told you the general concept of back propagation. Once we make the forward pass, we use certain values of weight pass in the first layer, certain values of weight pass in second layer. We reach the output, then we make the prediction compare with the actual, then we make the back propagation, and each layer we take the derivative and then adjust the weights for that layer, then the second layer derivative, adjust the weights and bias, and then so this is how this is done, and this is known as back propagation. I hope you have understood this concept.